Good morning, year 11s. We conclude chapter 5 on functions with looking at inverse functions. So, do you remember that the meaning of a one-to-one function? So, for each y value in the range of the function, there is exactly one number x which is in the domain. So x is linked to the domain, and for the y value is to the range. So, and the rule is f of x equals y, or y equals f of x. Once you know that the function is a one-to-one, then we can define an inverse function, so inverse of f, and the notation is f with that notation to the power of -1, but it's not a power function, it's just the notation for the inverse. And as we define f of x equals y, to define the inverse, all we need to do is change the function to the inverse function. And to get to the next one, if, and that's the critical part, is when you have a function f of x equals y, if you swap around the variables, okay, you swap around the variables, you get that new expression. That's the definition of the inverse function, which is equivalent to that first part, how it is defined. And for the x values on the inverse function, now it's the range, and the y values now are elements of the domain. So the domain and range of the function f, when you swap them around, will give you the respective domain and range of the inverse of f. Alright, let's apply that to, before we apply that to a general function, let's look at a function that is defined as a set of points. So you have an ordered pairs of points. Notice with the x coordinates, so you have 1, 3, 5, 6, 0. Corresponding, you have 2, 4, -1, -7, and 6. There actually no repeat, so it is a one-to-one function. So the first thing is you want to describe the inverse function here and define the domain and range of both functions. Alright, to define the inverse function, you take the pairs, and what you do is you swap around the coordinates. The way they do it is you start with, let's say for the first point, 1, 2. It's f of 1 equals 2. When you apply the inverse function, you swap around the 2 and 1, and that defines your inverse functions. So basically you're swapping around the coordinates, okay? And from reading the coordinates, so let's go back to the function f. You read the x values and you can list them in order. So actually no, just leave them the way they are at this stage for this, because it's a pair of ordered pair. Just leave them as they are. So you list the x values for the domain, you list the y values for the range, and you could do the same for the inverse functions, but simply what you need to do is the domain is going to match the range, and the range is going to match the domain of the inverse function. Okay, so to summarize, the when you have a function f and an inverse function defined, to find the domain and the range, you just swap around the range and domain of the original function f. Okay, now where is this coming from is, let's look at the geometric meaning. In yellow, we have our inverse functions, inverse function here and f in blue there. Let's start with a point on that function, which the coordinates are x and y. Okay, also the point y and x belongs to the function f, okay, which is over there, by just swapping the x and y coordinate. What it also means graphically is, if you draw your line y equals x in dash red, another way is, if your Cartesian plane is the same vertically and horizontally, like you have the same measurement, you can also measure 45 degrees. But basically any point on that line will have the same x and y coordinates, so that should be really quick to draw. You should extend it to the negative part as well, just a good habit for a line. And what you do is you do a reflection from the from that line. Just notice you have a right angle here, and also those two lines, if you use a ruler, they're gonna have the same measurement. Okay, now to graph that, what I find is, just give me a sec. So with that line, what I find is, let's say you have your yellow curve. To graph the blue curve, what I suggest initially, when you're not familiar with it, is turn this vertically. Okay, so you see that line y equals x is vertical, and use that as an axis of symmetry or mirror. So whatever you have on for, let's say, your function f in blue, do a mirror image of your inverse function to get a graph of it. Let's continue with more examples. Example A, you have a function that is a linear function. So 2x minus 3. Sketch the graph of the both functions. With the next one is the same linear function, except that new function has a restricted domain, so just pay attention to that. And then you will have to find the range, and eventually you should be able to state the domain and the range of the inverse function. Alright, from the function rule, what you do is, with the f of x, just write y equals 2x minus 3. So we have our pair of coordinates, and to get the rule of the inverse function, what you need to do is interchange x and y. So you can see below, it's the same rule, except y and x and y are swapped around, and that is the graph, the equation of the inverse function. Now what we need to do is do a little bit of algebraic manipulation. So solve for y, and you rearrange it, you follow the working out, you get a new straight line. So notice how you started with a straight line. The inverse function is also a straight line. The gradient is going to be different, and the y-intercept as well. You don't necessarily need to factorize it. So if I expand it, it's half of x plus 3 over 2. Please write fractions, don't use a approximation of decimals. So here is the rule for the inverse function. Knowing that to find the domain and range, find for that straight line f, the domain of f is R, so we can get the range of the inverse function. Then the range of f is R as well, and we can find the domain of the inverse function. Okay. Alright, so the original function f is in yellow. Okay, it has a y-intercept of -3 and x-intercept of 3/2, so you can use these intercepts to draw that straight line. And again, what I would do is rotate that picture slightly. Let me do that. So let's say you started with your f function in yellow. What you would do is draw your line in red, y equals f of x. Okay, and then just do a mirror image and you'll get the blue curve straight away, which would be your inverse function. Alright, so we'll get the blue line with that new rule, which is half of bracket x plus 3. Use the intercepts to get a more accurate graphing, as well is something that is gonna be just make it a bit more accurate, is the point of intersection. To find the point of intersection, y and x must have the same values, because that's the rule, y equals x. If you make those two y's, this is the y of the inverse rule, and up there we have the y of the function f. You make them equal, you solve it, and you will find the x and y value of that point of intersection. Alright, moving on to part B, the same rule. The domain is restricted to 2 and 6. Find the endpoint by substituting those 2 and 6 into the function g. We get 1 and 9. Now, knowing that this function, also you can read it from the graph. As you look at the curve, you can see the lowest and highest y values. But here is an explanation from the rule. The gradient is +2, which is positive. It means the function is increasing, so the minimum will be 1 and it will increase towards 9. So the range is therefore 1 to 9 included. As we have the domain, we just determine the range by swapping them around. So that's the range and that's the domain. That will be the domain of the inverse function and the range of the inverse function. And the rule has been calculated in part A. Let's continue. Another example. So here is a quadratic function. Now if you remember, a quadratic function is a full parabola. If you do a horizontal line test, it will not be a one-to-one function. But bear in mind the domain has been restricted to 3 to 6. So now it is a one-to-one function. So you can determine the inverse function, and you will also need to state the domain and the range. So the range is going to be the domain of that, but you will need to determine the range of the function f to find its domain. The rule is you have y instead of f. The inverse function has the following rule: you swap around, so y becomes an x, x becomes a y, and you need to rearrange it to make y the subject. Now when you square root, you will have a positive and a negative, so you'll have two possibilities. But as I just mentioned before, the domain of f is 3 to 6, so the range of the inverse function is 3 to 6 as well. 3 to 6 is a positive range. So when you have a square root, you can't have the negative part of it. So the inverse function is restricted to positive 3 root x. To find the domain, what you need to do now is for the 3 to 6, so let's look at my function in yellow. That's my function f. The domain is 3 to 6. To find the y values, we substitute into the rule. We get 1 and 4. And you can see as the function is increasing, the range of f is going to be from 1 to 4. Therefore, it's going to be the domain of the inverse function. So the domain is 1 to 4, the range is 3 to 6, and the rule is 3 root of x. Now to get the graph, you should know how to draw your parabola, which is f. Draw your line y equals x, tilt it on the side, draw the endpoint as a by swapping around the coordinates. So 3 and 1 becomes 1 and 3, or you can do a reflection from the line. And then the blue curve is kind of approximated to be an image of the yellow curve. Okay, last example. So we have a different quadratic. Again, the domain is restricted, so the function has an inverse function. You need to find the inverse function, so you don't have to worry about the domain and range. So to find the inverse function, you still need to pay attention to the domain. So for the inverse rule, you swap around again. That's your y. So you're going to swap around to an x, and the x in our x function will become a y. You need to rearrange it to make y the subject. Again, we have a plus minus square root, but we know the domain is from 1 to positive infinity, so that will also be our range for the inverse function. So the inverse function is restricted to the sum. We remove the difference, so it's going to be 1 plus root x minus 4. To find the domain, it's going to be the range. So the endpoint is when you have x equals 1 is you substitute in the rule that gives us y equals 4, and that will give us the range starting from 4 to positive infinity. Now there is a graph, but that's not really necessary. But let me go, and what I do is, as we're finishing with this, if you wanted to graph you will draw your straight line y equals x, then any particular point. So here I have 1 4. If I swap around the coordinates 1 4, I will get 4 1. That will be should be somewhere over here. Now the Cartesian plane is not scaled properly, okay, so 4 1 is not really looks really close to the 1, so just ignore that for a second. And then what you would do is use a gray, try to do something that looks not what I'm doing. I'm using a mouse, but okay, so that looks like a vase. So this should be the symmetry of the red curve. Okay, so that's what you would do if you were to sketch the inverse function of that function f. So here that's my f, and here will be my inverse of f. Alright, and that's it for today and chapter 5, and I'll see you next time.